In this video, we are going to design our architecture, which is the microservice architecture with the implementation of SAGA, transactional outbox, and change data capture patterns. Now, before design any architecture, we should ask ourselves what we have in our design toolbox and what we have learned so far. Let's remember what we have learned in the last section. As you remember that in the last section, we have finished the microservice data management commands and queries. Here you can see the pattern and principles, and here you can see our patterns. We have implement data management patterns in the last section, and these are the related pattern and principles, which is the choosing the right database. We learned these patterns, and after that in commands and queries under the Microsoft data management, we will learn CQRS, event sourcing, eventual consistency pattern and principles. So after that, in the microservice data management part, we have one more sub item, which is the distributed transactions. So now let's focus on what we have learned in this section. In this section, we have learned microservices distributed transactions. I'm going to write down the related architectures. Here you can see that we have finished the data management pattern, and we have focused on the microservice distributed transaction patterns. And here you can see all related patterns, which including the data management patterns. And also here you can see that in this section we have learned microservice distributed transaction management pattern and best practices. So these are the SAGA pattern for distributed transactions, which including the choreography and orchestration based SAGA pattern. And after that we will learn compensating transaction pattern, and also we will learn dual write problem, and we will learn transactional outbox pattern, and after that we will learn change data capture principle, and we will also see how Apache Kafka and Debezium perform change data capture, and how cloud database like CockroachDB, Azure Cosmos DB, or Amazon DynamoDB performs change data capture in their architecture. So now with this learning, we can refactor our design, and after that we will design our latest architecture. Here you can see the final architecture design for our e-commerce application, which is applying microservice architecture with SAGA, Outbox, and change data capture patterns. Basically, we have four main microservices, which are the product, shopping cart, discount, and ordering microservices. And also in this architecture, we have added order fulfillment microservices, which are the inventory, shipment, and payment microservices. So here you can see that how we can apply all these pattern and principles in this architecture. As you can see that we have applied the transactional outbox pattern in here, and after that we will perform change data capture, and this will be avoid the dual write problem. And after that this will be publish event automatically to the event bus, and this event will be consumed from the fulfillment microservices, which will be implementation of SAGA pattern, and we will combine of these SAGA, Outbox, and change data capture patterns. So let me explain from the beginning. In a microservice architecture, change data capture can be used in combination with the Outbox pattern in order to synchronize data between microservices. So the transactional outbox pattern is a way of ensuring data chains made by a microservices are eventually propagated to other microservices that depend on that data. It works by adding a new table, which called an outbox table, to the database of each microservices. So whenever a microservice updates data in its database, it also writes a record to the outbox table with the details of change. So change data capture can then be used to monitor and the outbox table for new records and extract the data changes contained in those records. The extracted changes can then be propagated to the target microservices or other systems that need to be kept up to date with the data. Using change data capture in combination with the transactional outbox pattern that allows microservices to decouple their data updates from the process of propagating those updates to other microservices. So that means these will provide to avoid dual write problem. So you can see the latest design of our e-commerce microservices with using SAGA, Outbox, and change data capture. And we have illustrated that create order use case with the fulfillment steps of the ordering process. So this will start from the client application which requests for the create order request, and this will be continue from the order fulfillment process. So let me explain step by step. The first step is creating any order record into order table, and creating any order created event into Outbox table are in the same transaction, and this will be the transactional Outbox pattern. That means we create any transactional Outbox table serving as a repository of change events in the same database schema as source tables. Microservices updates the source table and create a change event in the Outbox table in one single ACID transaction. If one of the processes fails, this will be rollback the whole operation with the following ACID principles, so that will provide not publishing any event in the same transaction. After that, after successfully writing the order table and Outbox table, we can perform a log-based change data capture from these Outbox table using the Debezium or any change data capture supported database like CockroachDB, CosmosDB or DynamoDB, and create events and insert item into event bus like Apache Kafka topic. So basically with change data capture, it is automatically capture the change from the Outbox table and publish events to the event bus, which could be Apache Kafka. And change data capture track every time any order is placed or an order is updated or an order is deleted. So this will be triggered automatically. This information can then be sent to another system such as an inventory and shipment microservices to start fulfillment process of the order and keep data up to date with the latest orders. So this is the event driven architecture that implements choreography based SAGA pattern with sending events for every step of distributed transactions. And other microservices will then connect the Kafka topic and consume these events for downstream processing. In our case, these are the inventory, shipment and payment to provide order fulfillment process.